Today we're looking at lesson 11.9, volume of a rectangular prism. And it says, how can you find the volume of a rectangular prism? We've really kind of already been doing this. We've been doing it with different units of measure. Yesterday we used the crayon boxes. We've used our unit cubes. And so you can find it in multiple measurements. But really, it is all about taking the length times the width times the height. Okay, so this is on your little connect right there. The base of a rectangular prism is a rectangle, right? Okay. You know the area is measured in square units or units squared. Remember when we would take the length times the width to get the area of a rectangle, if it was 4 blocks by 5 blocks, that was in, if we used our centimeter cubes, it was in centimeters squared, meaning it's a 2-dimensional figure. So the area of the base is length times width, and that's measured in units squared. Volume in cubic units or units cubed. When you build a prism and add each layer of the cube, you are adding a third dimension of height. So the square area of the base is how many square units is in that little rectangle they have drawn there. How many? You can't count them or tell me it's 3 by 4? So it is 12 square units or units squared. That's the area of the base of a rectangular prism. Here we are on the unlock the problem. Sid built a rectangular prism shown using 1-inch cubes. So if I had 1-inch little square blocks that were 1 inch on each side. The prism has a base that is a rectangle. So the bottom of this forms a rectangle. Okay? And has a height of 4 cubes. So they stack 4 layers of cubes on top of each other. What is the volume of this rectangular prism that Sid built? Now this is one way you can do this. Each layer of Sid's rectangle is composed of what? How many inches? Of what inch cubes? How many inch cubes are there? 4. It's 3 this way and 4 this way. So it's 12. Multiply the height by what? How high is this? 1, 2, 3, 4. So the height is 5. And what are we going to multiply that by? 12. 12. So if you look at this in layers, this layer is 1 times 12. We add this layer, that's 2 times 12. What's 3 times 12? 36. And 4 times 12? 48. Whoops. Are there 5 layers? 4. 4 layers. Let's try that again. 4 layers. Okay. So the volume of this cube is 48, and what were we measuring in? Cubic inches. How does the volume change as each layer is added? What did we add each time? What's our pattern? 12. Yes, the volume increased by the number of cubic units in each layer. 12. So every time that they stacked a new layer of blocks, they were adding 12 cubic units. Just like in your chart. The bottom layer was 12. We added another layer of 12, which made it go to 24. Then another layer, So now we had 3 layers of 12. Okay, it says, what does the number you multiply by the height? We were multiplying by 12. What did that represent? The area of the base of our pyramid. Because it was 3 times 4. The area of the base shape, or the number of cubes in each layer. So when we multiplied our length times our width, we got 12. The question is, what does the number you multiply the height by represent? It represents the area of the base shape, or the number of cubes in each layer. So the volume of Sid's rectangle is 48 inches cubed. So you can write cubic inches, or you can say inch with a period, remember, with the little 3 to show that it's cubed. Okay, we've moved on to page 476. And one way, let's read the relate height and volume at the top. I don't have it on my PowerPoint, but Tony stacks cubed shaped beads that measure 1 centimeter on each edge of a storage box. The box can hold 6 layers of 24 cubes with no gaps or overlaps. What is the volume of Tony's storage box? What is the dimension of the box? It can hold 1 centimeter each. The box can hold 6 layers of 24 cubes. So what might the dimension of the base of the box be? What would make 24? 4 by 6. Okay, so 4 centimeters and 6 centimeters. That's not what you need to write on the line in the first little purple box up there. 4 centimeters and 6 centimeters on the first line of the little purple box. 4 centimeters and 6 centimeters. What operation can you use to find the area of the base shape? What do? We add, subtract, multiply, or divide? Multiplication. That's what you need to write on the second line. Multiplication. Well, it says, one way, use the base and height. The volume of each bead is what? What does it say? Cube-shaped beads that are 1 centimeter on each edge. So 1 centimeter by 1 centimeter by 1 centimeter. 1 times 1 times 1 is always 1. The storage box has a base with the area of 24 centimeters squared, and the height of the storage box is 6 layers, or 6 centimeters. If I measured it, would be 6 centimeters. The volume of the storage box. What was the area of our base? 1, 2, 3, 4, 5, 6. By how many beads? 1, 2, 3, 4. Oops. That's supposed to be, sorry. That is supposed to be 24. By how many layers are there?
6.
6 layers. So 6 times 24. 24 times 6. 144 centimeters cubed. So the first thing we did was find the area of the flat surface that it's sitting on. Then we multiplied it by its height. So you can take the area of the base times the height. Do we know how to find the area of the base?
Yes.
How do we find the area of the base?
You take the base.
We take the length times the width. So base is equal to length times width. Okay, so now we're going to look at this in another way. Use length times width. Use length, width, and height. You know that the area of the base of the storage box is 24 centimeters cubed. The base has a length of what? How long is it across here? 6. And a width of 4. And the height is 6. The volume of the storage box is, how did we find the base area? Length times width, and then we multiply it by height to get our volume. Or, what was our length? 6. And what was our width?
4.
And what was our height?
6. Equals 144.
Okay, let's look at this again. I wrote the letters in instead of the numbers. So, the length was 6, the width was 4, and the height was 6. So we do 6 times 4, which is
24.
And our height is 6, or 144 centimeters cubed. So the volume of the storage box is 144 centimeters cubed. What you really need to remember is this. Volume is equal to length times width times height. So we learned 2 formulas today that you will use later when you start doing some more algebra and things, or you get into geometry. You will need to know that the base is equal to the length times the width, and that the volume is equal to length times width times height. Now sometimes you'll know your volume, but you won't know, maybe you won't know the length, but they'll give you the width and the height. So you'll have to figure out what the length was. Okay, so this is our hot problem down at the bottom. It says, what if each cube-shaped bead measured 2 centimeters on each edge? How would the dimensions of the storage box change, and how would the volume change? First of all, what would each of these cubes be? Instead of each cube being when we first started, it was 1 by 1 by a height of 1. Now they're telling us that each of these cubes is 2 by 2 by 2. So how is, the first question is, if each cube bead-shaped bead measured 2 centimeters on each edge, how would the dimension of the storage box change? It would now be not 6 centimeters, but this would be
12.
And this would be
8.
And this would be 12. Okay? So each dimension would increase by a scale of 2 or be twice as long. The volume then would be 2 times 2 times 2, or 8 times as much as what we found when it was 1. Okay, I'm going to type. So each dimension would increase by a scale of 2 or be twice as long. 12 centimeters, 8 centimeters, and 12 centimeters. the volume would be 2 times 2 times 2, or 8 times as much.